All right, we'll get to start into chapter 2 here now. So chapter 2 is all about summarizing and organizing data in tables and graphs, and that's where we see like the the different graphs, the charts, the tables, and things like that. Okay, so that's what we're going to be focusing on here in chapter 2. I had this kind of split up into two sections, and this goes along with what the book is doing too. So we're going to first talk about organizing qualitative data, and then we'll turn our attention to quantitative data in the next section. Okay, so a definition there: a frequency distribution lists each category of data and the number of occurrences for each category of data. Okay, relative frequency is the proportion of observations within a category and is found to be using the formula relative frequency equals, we take the particular frequency and divide by the total, the sum of all the frequencies. And then a relative frequency distribution lists each category of data and the relative frequency of each category of data. Okay, so let's take a look at problem 1 here, where it says that a phlebotomist draws the blood of a random sample of 50 patients and then determines their blood types. The data is shown below. Okay, so here's the different blood types of the 50 individuals. And we want to do a couple things here. So part A says to construct a frequency distribution and a relative frequency distribution for the data. Lists each relative frequency as a decimal. Okay, and by the way, from what I've noticed in your book, many times the relative frequencies are going to be in decimal form. Okay, so not in fractional form, but sometimes they will be. Okay, it just kind of depends. So make sure that you're reading the directions there in my math lab so that you understand what's going on. In the frequency distribution, I create a table, and on one side of the table, I have the different blood types, and on the other side of the table, I have my frequency, or my relative frequency, okay? And so I'm going to make a frequency distribution first, and by the way, make sure that the column headings are there. So the blood types, there's 4 different blood types, A, B, B, and O, and the frequencies. Okay, so I'm just going to count up the number of times that I see blood type A listed, and I should see blood type A listed 18 times, if you were to count that. Okay, blood type AB is listed 4 times. Blood type B is listed 6 times. And blood type O is listed 22 times. Okay, and if you add up all those numbers in the frequency column, you get 50 as the total. By the way, it's a good idea to add up the total and make sure that you've got, the total that was given to you in the sample. Okay, because if I was only getting like 49, or if I was, somehow getting 51 or something like that, there's obviously a mistake in what I've counted there. Okay, and then I want to attach a relative frequency column to what I've already got here. And so how I calculate a relative frequency is I take the frequency divided by the sum of all the frequencies. So in other words, how I'm getting this 0.36 here is I'm going to take 18 divided by 50. Okay, and 18 divided by 50 gives me 0.36. Okay, and so continue to do that. 0.4 divided by 50 is 0.08. 6 divided by 50 is 0.12. And 22 divided by 50 is 0.44. Okay? If you add up the relative frequency column, you will always get 1. Okay, and they said this is always going to happen. Okay, now what if you get like a 0.999 or like a 1.001 or something like that? Is there necessarily a mistake? No, there's not necessarily a mistake because of the rounding error that could happen. I mentioned that many times you're going to be using decimals, instead of fractions. Okay, or that's what I've noticed that the book is doing. Okay, so because rounding is a factor, there could be some rounding error going on. And so if I was getting like 0.999 or 1.01 or something like that, there's not necessarily a mistake. As long as all these numbers were rounded correctly. If one of these were not rounded correctly or something like that, and by the way, I didn't round any of these numbers at all. All these are exact, but many times there will be rounding going on there. Okay, and so there's not necessarily a mistake. Part B, according to the data, which blood type is most common and which is least common? Okay, so we can see that from our distribution here. O is most common and blood type AB is least common. Okay, anyone know their blood type? AB is the least common one here, and that in general is true. So I believe it's only like 3.8% of the world is blood type AB. Okay, so in general, that's the least common blood type. And O is sometimes called the universal blood type. Okay, so O is in general is most common. Almost half the world has blood type O. Okay. Part C, use the results of the sample to conjecture the percentage of the population that is blood type O. And then they want to know, is this descriptive, or is this a statistic descriptive or inferential? Okay, so from the distribution, I would guess that 44% of the entire population of the world is blood type O. Okay, just based on what I see here in the sample. Okay, now, is that statement a descriptive statistic or an inferential statistic? Well, that'd be an inferential statistic, because anytime you're extending your knowledge out from just the sample and measuring the reliability of this result for the entire population, then you call that an inferential statistic and not a descriptive statistic. So a descriptive statistic, again, is just information about the sample. I could also conclude that 44% of the sample is blood type O. Now that would be a descriptive statistic. Okay, but from that, I'm saying that, well, I would guess that 44% of the world is blood type O. Okay, well, that becomes an inferential statistic. Definition next says that a bar graph, which is generally used for a qualitative variable, is constructed by labeling each category of data on a horizontal axis and then the frequency or relative frequency of the category on the vertical axis, depending on what type of bar graph you're going to make. Okay? When constructing a bar graph, we use rectangles of equal width for each category, and then the height of each rectangle is equal to the category's frequency or relative frequency. Okay, so problem 2 says to use the distributions you made in question 1, that's right here, okay, to construct a frequency bar graph and a relative frequency bar graph. Include the height of each bar and label both axes in each graph. Okay, so when I make a frequency bar graph, I want to label I need my labels there. Okay, so this is my blood types, A, B, and O, and the frequency axis. Okay, and depending on the frequency that we've got here, so the largest frequency that I've got listed is 22. Okay, so I'm going to need a scale that goes at least to 22. Okay, and what I decided was to have a scale that starts at 0 and goes up to 25 in increments of 5. Okay, and then I draw each bar at a height according to the frequency. Okay, so 18 people had blood type A, 4 people had blood type AB, 6 had blood type B, and 22 had blood type O. Okay. I've got a note here, don't make the bars touch. Okay, when they do touch, it's special, okay, because we call it a histogram. And we're going to be doing lots and lots of things with histograms, okay, in the course. Okay, but when you just make a regular bar graph, as is the case here, you don't want the bars to touch. Okay. And then we want to make a relative frequency bar graph. So I had labeled the axes, my blood types axis and my relative frequency axis. Sometimes I see students make a mistake in the rate frequency or something like that. Don't do that. Okay, so this is a relative frequency axis. And then I want my scale. Now, according to the relative frequency table that I've got listed, I need something that's going to include at least 0.44 in it. Okay, because that's the biggest relative frequency that I've got there. So what I decided was to begin that axis at 0 and go up to 0.5 using an increment of 0.1. Okay, so there's 0.1, 0.2, 0.3, 0.4, 0.5. And again, I want to label each axis. So there's blood type A, B, B, and O. Okay, and then I'm ready to draw my bar graph. So I got both the axes are labeled, and the number lines look good. And let's see, the relative frequency for people of blood type A in the sample is 0.36. Okay, the next one for AB is 0.08, and then 0.12 and 0.44. Okay, and again, I want to make those not touch each other. Okay, now one thing that I want you to notice here, when you look at these two graphs side by side, they take on the same shape. This will always happen. Okay, why do we want to make a relative frequency graph instead of a frequency graph? Well, anytime we're dealing with percentages of the whole, we want to look at the relative frequencies. Okay, it says relative frequencies are needed when we want to look at percentages or portions of the whole. Okay, I've got a note here, scaling. So watch out for graphs that start the scale at some other value than 0. We will see that. Have different or have bars with different colors. Okay, so sometimes with the bar graph, you'll see the bars have different colors. Okay, you got to be careful with that. Or 3D bar graphs. 3D graphs look very neat. Okay, but you got to be careful about that because you could misrepresent the data. Okay, we'll talk about misrepresenting data kind of towards the end of this worksheet here. Okay. The next type of graph to know is called a pie chart, or a circle graph, they sometimes call it. And that's a circle that's divided into sectors. Each sector represents the relative size of each category of data. Okay, so problem 3, I want to complete the pie chart to represent the data from question 1. Okay, and that was with the blood types. In each sector, write the blood type and the percentage of area represented. By the way, when you make a pie chart, typically you use percentages, okay, not the relative frequencies. Okay, so I don't want 0.44, I want 44% listed. Okay, I've already got this drawn out. I used a computer to do that. So the biggest sector would be for blood type A, and 44% of the sample had blood type A. The next biggest sector is for blood type O. Excuse me. The next biggest sector is for blood type A, so 36% had blood type A. The smallest sector is for people with blood type AB. Only 8% of the sample had blood type AB, and then the remaining sector would be for people with blood type B. Okay, 12% of the sample had blood type B. Okay, so this would be my completed pie chart You usually want to label a pie chart. This pie chart represents the different blood types from the sample. Now, the emphasis on a pie chart is comparing a part to the whole. Okay, that is, if we wanted to get the big picture about a variable, then a pie chart would be a good visual summary. Okay, can you think of a disadvantage in making a pie chart by hand? Well, the angles are often hard to judge and typically would require the use of a protractor or for creating the sectors. So I mentioned that I had a computer, generate this blank pie chart for me. Like, that would be very difficult to draw this by hand, and have exactly 44%, exactly 36% showing. So, it'd be easier to have a computer do that. Since bars are easier to draw and compare, some practitioners forego pie charts altogether in favor of bar graphs. So you see that. Also, for an ordinal variable, so we talked about nominal variable and an ordinal variable. By the way, blood types is an example of a qualitative variable. I don't have numbers here, so I can rule that out, right? And this is an nominal variable. Okay, so there's no order that makes sense here. Okay, like unless you change the variable, which I don't want to do. But for an ordinal variable, a pie chart is less desired because there's no natural starting point with a pie chart. With a bar graph, we can order the bars how we want. Whatever order that we want here. You could order the bars. So like if I wanted, blood type O to be listed first, well, that's fine. There's no problem with that. But there's no natural starting point with a pie chart is all I'm saying. Okay. So that's basically it with section 2.1. If you want to begin looking at the homework in 2.1, it's on page 68. You should be able to have a go at those problems when you get a chance there. And where it says organizing quantitative data, that's where section 2.2 begins. Okay, so I'll begin section 2.2 in the next video.